This is Network Prodigy with On Demand Labs, and today's lab is going to be a pretty good one. We are going to go over implementing DMVPN or Dynamic Multipoint VPN on Cisco routers. So what we're going to cover in this lab is how do we configure DMVPN? How do we verify that DMVPN is working as designed? What we're not going to cover though is DMVPN theory. So we're not going to cover what is DMVPN and why you should use it and how does it work. We're not going to cover some of the DMVPN terminology like the NHRP Resolution protocol or the NHRP server. So it's already assumed that you have a basic understanding of DMVPN theory, and you're really just watching this video because you want to see how does it work live and how to get it configured and verified. So that's what we're going to do here. Now let me come on over to GNS3 so you can see the topology I have built out. As you can see, it's not a pretty large topology. We're just going to be configuring DMVPN on routers 1, 3, 4, and 5. So when you're doing this lab, I don't want you to think that you have to configure a lab inside of GNS3 with 20 to 30 routers. You can configure DMVPN with as little as 2 routers, right? Or 3 routers, have 1 hub and 2 spokes. So I don't want you to think that you got to configure a DMVPN network with 1 hub and 30 spokes just to test it out. Okay, you can configure a lab pretty much as small as the one I have right here in GNS3. Right, so let's look at the first configuration, which is going to be the tunnel configuration. So this is going to be done on every single router in the DMVPN network. And essentially what we're doing is just creating the tunnel interface. So we're going to go onto the router and we're going to say interface tunnel 0. This 0 right here can pretty much be any number that you want. I'm just using 0 in my example. We're then going to give it an IP address. So this is the IP address of one of the tunnels. Actually, this is going to be router 1's tunnel IP. And we're going to use a 24-bit mask on all of them. We're then going to specify the tunnel source, which for each one of them is going to be their gig 0/0 interface. Then we're going to specify that the tunnel mode is GRE multipoint. Okay, what this is going to do is allow the router to form a tunnel out of this tunnel right here with multiple destinations at the same time. So when you typically create an interface tunnel or a tunnel interface on a router, you specify a tunnel destination, and the router is only going to be able to form a tunnel with whatever that destination is. But if you set the tunnel to be multi-point, then he can form a tunnel with multiple destinations at the same time. Another command that you're going to see, especially in the real world, is setting the MTU of the tunnel to 1400. And what this command does is it sets the maximum segment size, that's what MSS stands for TCP, to be 1360. Okay, the reason why you put these two commands on the tunnel is because you don't want to have to deal with fragmentation. Okay, so just to avoid that, we set the MTU of the tunnel to be 1400, and we set the maximum segment size for TCP to be 1360 bytes. And we're going to put this configuration on all of our routers. So let's copy this and let's start with router 1. Right, so I'm over here in secure CRT. I'm going to go into global configuration mode and I'm going to copy this. There we go. So now router 1 is done. See, the interface tunnel comes up. Okay, I'm then going to change this to 3 because we're going to copy and paste this onto router 3. Let's go into global configuration mode and let's paste it. There we go. And let's change this to .4 and let's paste this onto router 4. Let's go into global configuration mode and let's paste it. There we go. And finally, let's do this for router 5. So let's change that to a 5 and let's copy and paste this onto router 5. There we go. All right. So let's do a do show run interface tunnel 0, just so we can see the configuration that we have on all of our routers. And you can see it's pretty much standard across the board. Okay, I didn't know I was in privilege mode there, so let's just do a show run. And okay, that's right, I didn't do it on router 2, so let me actually get rid of him. Here we go. So router 2 is actually just an internet router. It's not part of the DMVPN network, right? So routers 1, 3, 4, and 5, you can see they have pretty much the same configuration so far. Only thing that's different between them is the IP address of the tunnel. All right. So now that the tunnels have been configured, let's now configure the DMVPN hub, which in our example is going to be R1 at our headquarters office. So to configure the DMVPN hub, you're simply going to say, I should say interface, not tunnel, but interface tunnel 0. And then this command right here, IPNHRP authentication, then we use a password of Cisco 123. This just adds some security to our DMVPN network. So routers that aren't authorized to be on the DMVPN network won't be able to join. Okay, the only way they're going to be able to join the network is if they are configured with this command right here, and the password is Cisco 123. So adds a little bit of security to our DMVPN network. This network ID command right here, what it does is it allows the router, or I won't say allows the router. Essentially, the router can be a member of more than one DMVPN network at the same time. What the network ID does is it separates the DMVPN network. So the router knows that, hey, this tunnel interface belongs to this DMVPN network. And if you have another tunnel interface, he belongs to another tunnel or another DMVPN network. So it just helps the router be able to identify which DMVPN network the tunnel belongs to in case it's part of more than one DMVPN network. And then this command right here, this NHRP map multicast dynamic command, this is what's going to allow you to run routing protocols over the DMVPN network that use multicast like EIGRP and OSPF. If you forget to put this command on the hub, what you're going to notice is those EIGRP neighbor relationships, those OSPF neighbor relationships to the spokes will not form. So if you're running EIGRP or OSPF as your routing protocol over the DMVPN network, you got to have this command configured right here on your hub. So let's copy and paste this, and we're going to paste this onto our hub, who is router 1. There we go. So now the hub is configured. Let's look at the configuration of the spokes. So the IPNHRP authentication command and the network ID command is going to be the same as it was on the hub. Okay. Now right here, the IPNHRP map, then we have the tunnel IP of the hub and the NBMA address of the hub, which is the hub's public IP. What we're doing is we're statically giving a mapping to the spoke of the tunnel IP of the hub to his NBMA address. Because when you go to build the GRE tunnel, it doesn't matter if it's a spoke or if it's a hub, when you go to build that GRE tunnel, you need not only the tunnel IP, but you also need the NBMA address. And this can either be a static mapping like what we have right here, or it can be a dynamic mapping. So we're giving them a static mapping to the hub, and then when they start learning the tunnel IP to NBMA mappings of the spokes, those are going to be dynamic mappings. So we're only going to do a static mapping for the hub. You could theoretically do static mappings for the spokes as well, but in really large environments, you wouldn't want to do that. You would only want to do a static mapping for the hub and let the spokes learn the other mappings dynamically. Okay, so this is going to be a static mapping for the hub's tunnel IP to his NBMA address. This command right here, NHRP map multicast 12.12.12.1. Again, this is the NBMA address of the hub. This is needed kind of like how this command was needed on the hub. This command is needed on your spokes if you're wanting to do routing protocols over DMVPN that use multicast, so OSPF or EIGRP. If you forget to put this command, then the neighbor relationship to the hub will not form. So if you're running EIGRP or OSPF over DMVPN, you got to have this command right here. And then this command right here, IPNHRP NHS. This right here is the tunnel IP of the hub. This is essentially telling the spoke the IP address of the next hop server, who is the hub. This is important because remember right here, we're only giving him a static mapping for the hub. When he tries to do the resolution for the other spoke's tunnel IP to the NBMA address, he's going to generate an NHRP request. and that NHRP request has to be sent up to the next hop server, which is the hub. So if you forget to put this command right here, he's not going to know where to send that NHRP request, and he won't be able to do the resolution of the other spoke's tunnel IP to his NBMA address. So you got to have this command right here so he knows who is the next hop server. Now we're going to take this and we're going to copy and paste this onto all of our spoke routers, which is 3, 4, and 5. But before we do that, I actually want to right click on this link and I want to do a packet capture, because essentially what should happen when we deploy the configuration on the spokes have to register with the hub. When we say register, it means the spokes have to reach out to the hub and say, hey, Mr. Hub, here's my tunnel IP, here is my NBMA address. Because if we come back to the configuration, we didn't put static mappings for all the spokes on the hub. Okay, the hub is going to have to learn all of this information dynamically, so it's up to the spokes to register with the hub and give them or give him this information. So as soon as I copy and paste this configuration right here onto router 3 should send an NHRP registration message up to the hub, who is router 1. And if we come over to Wireshark, let me do a filter on NHRP. We should see those NHRP registration messages coming through Wireshark. So let's come over to router 3. Let's get our configuration right here. And this is going to be done on the tunnel interface. So let's say interface tunnel 0. And let's now copy and paste that. There we go. And if we come back over to Wireshark, we can see we have an NHRP registration request. It's coming from the public IP of router 3. It's going to the public IP of router 1. Okay. If we look inside of this NHRP registration request, look at the mandatory part, you're going to see it has router 3's NBMA address as well as router 3's tunnel IP. Okay, and then router 1 responds with a registration reply saying, hey, I got it. So anytime you bring a spoke onto the DMVPN network, they have to, it's a requirement, they must register with the spoke, not the spoke, the hub, by sending an NHRP registration request. All right, so let me say interface tunnel 0, that way I don't have to type it out. And let's configure this on router 4. There we go. And let's configure this on router 5. There we go. And then we come back over to Wireshark. Here's router 4's registration request. And here's router 5's registration request. So anytime again you're bringing a spoke onto the network for the very first time, he needs to register with the hub and tell the hub what his tunnel IP is and his NBMA address is. It's important that the hub has this information so that he can build the tunnel back to the spokes. Okay. Remember, we gave the spoke the NBMA address and tunnel IP of the hub. We did it statically. The spokes then have to reach out to the hub and give him their tunnel IP and NBMA address. Okay, and that's what we see right here in the registration request. Right. So now that we have that done, we can now do routing. Right. And for my lab, I'm using EIGRP. So essentially all we're going to do is enable EIGRP on the tunnel interface and EIGRP on the loopback. So if I do a do show IP interface brief, let's exclude unassigned. You're going to see that each router has a loopback interface right here. So that's router 5's, here's router 4's, here's router 3's loopback, and here's router 1's loopback, as well as the tunnel IP. So we're going to come to router 1. Let's start with him. Let's change that to a 1. Let's change that to all 1s. Right, and let's copy and paste this. There we go. Right. Now before we get to 3, 4, and 5, you see right here, only do this on the hub. You only need to do this if you're using EIGRP. You're going to go to the tunnel interface. You're going to say no IP split horizon. This is going to disable this, and no IP next hop self. Okay, these commands are very important. You got to disable split horizon because when 3 advertises his loopback up to 1 over the tunnel, if split horizon is enabled, 1 is not allowed to send it back out of the tunnel to 4 and back out of the tunnel to 5. So we need to disable split horizon on the tunnel so that when 3 sends the update about his loopback to 1, 1 can send it back out of the tunnel to 4 and back out of the tunnel to 5. Just like in the reverse direction, when 5 advertises his loopback to 1, 1 gets it in the tunnel, but once we disable split horizon, he can send it back out of the tunnel to 4 and back out of the tunnel to 3. Okay, if you do not disable split horizon, the spokes are not going to learn networks from other spokes. Okay, and then this command right here, no IPNNHRP self. Essentially what we want to avoid is when router 3 sends an update to 1 and 1 sends it to 4 and 1 sends it to 5, where router 1 makes himself the next hop. We don't want that to happen because then all traffic is just going to go through router 1, who is the hub. When 3 sends his loop back to 1, we want 1 to maintain the next hop of being 3. So when 4 sees it, 4 is going to see that the next hop to get the 3's loop back is 3. If that's the case, they'll be able to build the tunnels between them. So we don't want the next hop to point to the hub. So that's why we're telling the hub, don't change the next hop to yourself. Keep the next hop as being the spoke you learned the update from. So let's take this command, and you only need to do this on the hub. So I only need to do this on router 1. All right. So now that that is done, let's finish our configuration of the routing. So let's change that to router 3's IP and router 3's loopback. All right, and let's copy and paste this onto router 3. And you can see we get a log message about a new EIGRP adjacency was formed. Okay, this happened to be the adjacency going over to the hub. All right. Put that there so it can automatically exit. I don't have to type it. So let's change this to router 4. Let's change this to router 4's loopback. All right, so let's come to router 4. There we go. Get a new neighbor adjacency over to router 1, which is great. And let's change this to router 5. And let's change this to router 5's loopback. All right. And let's now paste that. And there we go. Got a new neighbor adjacency over to router 1. Excellent. All right, so let's go back to privilege mode. Let's do a show IP EIGRP neighbors. You're going to see that router 1, being the hub, has 3 neighbors. He has a relationship over to 3, a relationship over to 4, and a relationship over to 5. Okay, and then 3 has a relationship over to 1, 4 has a relationship over to 1, and 5 has a relationship over to 1. And what I'm going to do, let me just make my font a little smaller. I think that's kind of big. Let's edit font. Let's make that like 14. All right, let's do that. What I'm going to do is I'm going to close out these sessions. I think I got the font just a little too big. So let's close all these out. Try to open it back up, see if it's a little smaller. There we go. All right, so let's open all these back up. All right, there we go. So router 1, he has an EIGRP relationship to 3, EIGRP relationship to 4, and to 5. Okay, and each of the spokes has one EIGRP relationship to the hub. Okay, let's do a show IP route EIGRP. So router 3, he's learning about router 1's loopback, but you can see he's learning about 4 and 5's loopback as well. And notice that the next hop IP to get to 4's loopback is 4's tunnel IP. And the next hop to get to 5's loopback is 5's tunnel IP. Okay, this is what you want to see. You don't want to see the next hop being the hub. You want it being the other spoke. Okay, just like if you come to 4, the next hop to get to 3's loopback is 3, and the next hop to get to 5's loopback is 5. Okay, so that's what you want to see. So all of the routers are learning all of the other routers loopbacks through EIGRP. Let's now do some verifications. So we come down. First verification is going to be a show DMVPN. This is going to show you all of the tunnel IP to NBMA mappings you currently have. Let's do that on all of our routers. Show DMVPN. So on router 1, he has 3 mappings. He has a mapping for router 3, a mapping for router 4, and a mapping for router 5. All of these mappings were done dynamically, meaning we didn't statically put these mappings on router 1. Router 1 learned these mappings when the spokes registered with him. Okay, that was through these resolution or these registration requests that the spokes sent to the hub when we first brought them on. Okay, I don't need that. All right, routers 3, 4, and 5 being the spokes, they're going to have mappings for the hub, but these are static mappings. That's because we statically configured them for the mapping with this command right here. Okay, and my laptop is trying to die on me, so give me 1 second. Let me plug that in so it doesn't die on me. Okay, I am back. Got my charger plugged in, so I don't have to worry about my laptop dying. Let's come back to secure CRT. So we can see all of the spokes have mappings for the hub. The next verification command is going to be show IPNHRP detail. This is going to show you all of the tunnels that have been built. So we do a show IPNHRP detail. Let's first start with the hub. You're going to see that the hub has 3 tunnels that have been built, all of them going to the spokes. And you can see it's being built out of the same tunnel interface. That's because this is a multi-point tunnel interface. So he has a tunnel that's built to router 3. That's the tunnel IP. That's the NBMA address. He has a tunnel built to router 4. This is his tunnel IP and his NBMA address. And here's the tunnel built to router 5. Here's the tunnel IP and the NBMA address. Remember, the NBMA address is the public reachable IP address. If you come over to router 3, 3 currently has 1 tunnel built. It's going over to router 1. This is router 1's tunnel IP, and this is the NBMA address. Okay, 4 and 5 are going to show the same exact thing because they're all spokes. Okay, so 3, 4, and 5 all have 1 tunnel built, and router 1 has 3 tunnel built, all going to the spokes. Then you can do show IP NHRP NHS. This only needs to be done on the spokes. This is basically going to show you if the hub is up and reachable. So you come over to router 3, you do that, you can see you have the hub right here. He has a status of RE, meaning he is responding and he's expecting replies. So everything is great. Okay, you do the same thing on router 4. Show IP NHRP NHS. Same thing. The hub is responding and he's expecting replies. All right, and go over to router 5. Same thing. He's responding and expecting. So everything looks great. We have the tunnels built from the hub down to the spokes. Everything looks great. Now let's test it out. So what we're going to do is come over to router 3 and let's do a show IP route for router 5's loopback, for example. So we learned this via EIGRP. We learned it over the tunnel, and the next hop is going to be router 5's loopback, or the tunnel IP of router 5. So this is what should happen. Okay, we do a show DMVPN. There's no NBMA address to tunnel mapping for router 5's loopback, right? So right now 3 and 5 do not have a tunnel built between them, and when we do show IP NHRP detail, there's no tunnel built between 3 and 5. So if I were to do a trace route to router 5's loopback and I source it from my own loopback, you're gonna see that the traffic flow initially goes through the hub and then down to router 5, because 3 didn't have a mapping for router 5 and the tunnel wasn't built. So now router 3 is like, okay, instead of sending traffic to the hub, I want to be able to send traffic directly to router 5. So you know what router 3 is going to do? He's going to generate an NHRP request message. So if we come back over here, here is the NHRP resolution request that came from 3 going to 1. Okay, if you look inside of this, it has 3's NBMA address, his tunnel IP. It also has the tunnel IP of router 5. So when 1 gets this, he's like, okay, I need to forward this to whoever owns this tunnel IP, right? This is why it's important that the spokes register with the hub. So we come over to router 1, we do a show DMVPN, which was up here. Router 1 knows that for this tunnel IP, this is the NBMA address, and he already has a tunnel built to router 5. So you know what he's going to do? He's going to forward this resolution request down to router 5, right? So it's coming from router 1, now it's going to router 5. So when router 5 gets this resolution request, he's going to open it up. He's going to say, oh, here's a source NBMA address and here's a tunnel IP, right? This happens to be the information for router 3. So if we come over to router 5, okay, we scroll up. Previously, all he had was the hub's information, right? Because we gave it to him statically. But we do a show DMVPN again. Well, now he has 3's information. Here's 3's NBMA address. Here's his tunnel IP. And notice this has AD, meaning dynamic. So 5 learned this information from the NHRP resolution request. So now what 5 has to do, and you're not going to see it because I'm capturing on this link. I think next time when I do router 4, I'll capture on this link so you can see it. But 5 is then going to generate an NHRP reply message. But instead of sending it directly to router 1, 5 is going to send it directly to router 3. And when 3 gets it, he's going to look inside of the reply, and it's going to include router 5's NBMA address as well as the tunnel IP. So we come over to router 3. Okay, previously when we did a show DMVPN, all he had was router 1's information. But thanks to router 5 sending the NHRP reply, we do a show DMVPN again. Now he has router 5's information. He has the NBMA address. He has the tunnel IP. And this is a dynamic mapping. So now if I do a show IPNHRP, you're going to see we now have a new tunnel that has been created. It's now going over to router 5. Here's 5's tunnel IP. Here's 5's NBMA address. If you come over to router 5, do a show IPNHRP. 5 also has a new tunnel created. Going over to router 3. Here's 3's tunnel IP. Here's 3's NBMA address. So now that 3 and 5 have a tunnel built between them, when I do my trace route again, I should not see traffic going through the hub and then down to router 5. I should see traffic just going directly to router 5. So let's hit our up arrow key a couple of times, do our trace route again. Notice the hub is not in the picture. Traffic is just going directly to router 5, and it's avoiding router 1. That's really how DMVPN works. So initially, traffic went through the hub because the spoke had to do the tunnel IP to NBMA resolution. Once that was done and they were able to build a tunnel between themselves, well, now they don't have to send traffic through the hub no more. 3 can just send it directly to 5. All right, so let me capture this link. Let me actually close this one, and I'm going to stop capturing here. And I'm going to capture this one. All right, I'm going to capture this one. So let me come back over to router 5 now, and let's do a trace route to 4. Because the same thing should happen, right? If we do a show DMVPN, right now 5 does not have the NBMA to tunnel IP mapping for R4. It's not there. And if you do a show IPNHRP, right now 5 does not have a tunnel created and built going to router 4. So when I do a trace route, as a matter of fact, let's do a show IP route for router 4's loopback. The next hop is router 4. So what should happen is, since router 5 does not have the mapping for router 4 and a tunnel has not been built, 5 should generate an NHRP request message. And we're going to initially see traffic flow through the hub. All right, so let's see. Let's do a trace route to router 4's loopback. Let's source it from our own loopback. So notice traffic went through the hub, then it went down to router 4. All right. Now, if we come over to Wireshark, let's do a filter for only NHRP. So look at this. There was an NHRP request that came from the hub to router 4. So 5 generated the NHRP request, sent it to 1. 1 then forwarded this request to 4. Okay. 4 is going to get it and say, okay, this is an NHRP resolution request. I'm going to look inside of it, go to the mandatory part, and it's like, okay, 5 put his NBMA address as well as his tunnel IP. So I don't have to request this information from 5. 5 gave it to me. All right. And then I see my tunnel IP. So somebody's asking for my NBMA address. Right. So you know what I'm going to do? I'm going to put a mapping in my table for router 5. So if I do a show DMVPN, now I know about router 5. Here's his NBMA address. Here's his tunnel IP. This was a dynamic mapping, meaning I learned it dynamically. 5 gave it to me. Okay, me as the engineer, I didn't have to statically put this information here. 5 or 4 automatically learned it. All right. Now, what 4 has to do is 4 has to respond with a resolution reply. All right. So you can see it's coming from 4, but it's not going to the hub. This is router 5's public IP. So 4 isn't sending it back to 1 and then to 5. 4 sends it directly to 5. Okay, so it's coming from 4's public IP to 5's public IP. And this is an NHRP resolution reply. So if you look inside the reply, notice that it includes, is this the reply? All right, so this is the original information. You got to click right here where it says client information entry. This is where 4 is putting his NBMA address and his tunnel IP. It's right here inside of the reply. So we come back over to 5. Okay, originally 5 didn't have it. He only had a mapping for 1 and a dynamic mapping for 3. But if we do show DMVPN again, now he has a dynamic mapping for 4 based on what he saw in the resolution reply message. So now what should happen is 4 and 5 should be able to build the tunnel between them. So you do a show IP NHRP. 5 now has a tunnel to 4. Here's 4's tunnel IP. Here's the NBMA address of 4. You come over to router 4. Do a show IP NHRP. Here's the tunnel going to 4. Here's 4's tunnel IP. Matter of fact, no, I'm on 4. Here's the tunnel built to 5. Here's 5's tunnel IP. Here's the NBMA address of 5. So guess what? 4 and 5 now have a tunnel built between them, which means when I do my trace route again, which is right here, I should not see traffic going through the hub and then going down to router 4. I should see traffic going directly to router 4. So I hit my enter key, and there we go. Notice the hub is nowhere in the picture. All right, and that is how DMVPN works. So what I want you all to do is I want you to go into GNS3 again. You ain't got to make a huge topology, right? I only have 3 routers here, right? You can really do this with 2 routers. All right, I know you be seeing YouTube videos and people on Instagram where they be having thousands of routers like they're actually in a real enterprise environment. You don't got to do that. Okay, just configure you a real simple lab, because all you're trying to do is just learn this, right? You ain't got to be, too overly complicated in your lab, right? So just get you like, a little topology like this, and then this is the configuration that you're going to want to follow. Okay, so do the configuration, do the routing, do the verifications, and just kind of test it out, right? So do your trace route to see, traffic initially going through the hub. Do your capture so you can see the resolution request and the replies, right? This is going to help enforce everything that you learn. So when things are really working like they should, you should just see traffic going directly between the spokes and not through the hub. But that is it for DMVPN, and I'll see you guys in the next lab.